Let's continue talking about the IIA. That's what we started talking about last time. Actually, just to let you know where we're going, we're gonna finish up this whole voting systems business over the next couple times. Maybe next time will be the last of it, and then we'll move on to something also voting related, but quite of a different flavor. So if you're starting to get tired of this, then we're almost through. The IIA criterion, the independence from irrelevant alternatives criterion. It says that if you were to change around some of the votes without changing anyone's ranking relative to the winner, then the results won't change. For example, like if, let's say, B was the winner, and I change, if I had somebody voting something like A, B, D, C, and I change it, where B was the winner, I change it instead to A, B, C, D, right? That is viewed as an irrelevant change from the point of view of the IIA. This is an example where I changed some votes, but I didn't change anybody's ranking relative to the winner. If B was the winner, all I did was shuffle around the losers, and I kept the losers below B, and I kept the A was a loser, but I kept them above B. So I didn't change anyone's ranking with respect to the winner. So this ought to be irrelevant according to the IIA criterion, right? But with the voting systems that we've discussed, it's not always irrelevant. Like, for example, we saw last time that actually the Borda does not necessarily treat a change like this as truly irrelevant because, I mean, you can see if you're using the Borda here, this change will actually give more points to C, right? And it's possible, if I was using the Borda, that B was the winner, but maybe C was like a close second place, and a change like this might actually give C enough points to win. Now, this change will only give C one more point, but if there were several voters like this and you change them all, this could actually change the result if you're using Borda because it gives C more points and maybe C is going to win after you do this change. So this is something that we mentioned at the end last time. IIA is not satisfied by Borda. We did like a full example at the end last time. It's because when you make a change like this, even though you're not changing the ranking relative to the winner, you still might be giving somebody more points than they used to have, and that can cause them to win. That can actually change the outcome of the election. All right. Similar things, actually, similar kinds of violations exist in the plurality and the instant runoff. So, but rather than go through examples like this, I want to turn those into homework problems. So on the homework for next week, you will show also that plurality and instant runoff fail the IIA. All right. In those systems, it's also possible to change the result by doing one of these so-called irrelevant changes. They're actually not terribly irrelevant because they can change the result. All right. So as far as the and also on the homework, you're going to show that the dictatorship actually does satisfy the IIA. In general, you expect that most things are going to be not satisfied by the dictatorship because the dictatorship is not a nice democratic voting system. But actually, the IIA is about if you make some kind of change, it shouldn't affect the result. Actually, things like that are generally going to be true of the dictatorship because generally in the dictatorship, you don't change the result by making changes on the ballots. All that matters is what the dictator picked. So maybe this is not such a surprise. The dictatorship does satisfy IIA. All right, so if you are keeping track on the chart there, the IIA column looks like plurality. Actually, would you mind? This is actually the last time that we're going to that I'm going to write this chart, so I'm just going to try and write the whole chart down just to refresh everybody's memory. We got the plurality, the Condorcet method, the Borda, the IIA, and the dictatorship. And if you don't mind, I'm going to copy this off my paper just so that I don't have to think it through. Hopefully you have all of this business written down. We had the majority criterion, the Condorcet winner criterion, then we had the monotonicity, then we had the unanimity, and then we had the IIA, right? These are the ones that we've talked about. Actually, there are many, many more voting systems and criteria that people have talked about over the ages, mathematicians have looked at. Actually, if you look at, there's a nice Wikipedia article called List of Voting Systems, something like that, List of Voting Methods, which has a truly enormous chart with like 20 rows and 20 columns that looks just like this. This is a small part of the big chart that you can see if you look at that article on Wikipedia. Anyway, for the majority, it's a check and a check and an X and a check and an X. Hopefully you have all this already in your notes. I just want to take a look at the whole chart since we're not going to add any more onto this after today. Unanimity is satisfied by all of them. And the IIA is only, actually I did not mention one of these yet. The dictatorship does satisfy the IIA. Plurality and what I wrote IIA on the side. Sorry, that's supposed to be IRV. I mixed up my the instant runoff system. It doesn't make sense to put IIA down there, right? The instant runoff system. The IIA is satisfied only by the dictatorship of the methods. Although I didn't mention this one. I said on the homework, these two, the plurality and the IRV X's, you're going to work that out on the homework. What about the Condorcet method? If I change the votes, but I do not change anybody's ranking with respect to the winner, that means in those pairwise comparisons, actually you are not going to modify any of the pairwise matchups that involve the winner. And so the winner will still win. So there's a check in that column. The Condorcet does satisfy the IIA. Let me try and write some words to that effect. In the Condorcet method, one of these so-called irrelevant changes, an irrelevant change, which doesn't modify anybody's ranking with respect to the winner, that means it will not change who's winning all the pairwise matchups, right? If there was a Condorcet winner, they won all the pairwise matchups, they're still going to win after you make this change. So in the Condorcet method, an irrelevant change cannot affect the pairwise matchups involving the winner. And so that means the winner won't change, right? The winner, the results at the end will not change. So I'll say the result won't change. All right. So the Condorcet method actually does satisfy the IIA criterion. All right. Here's the chart. That's sort of where we're going to leave it. We could, if we wanted to, spend the whole semester talking about more and more voting systems and more criteria, but I think we get the feel for it. Let's take a look at the chart. What do you think, after all this time, what do you think is the best system? Well, according to the chart, you will notice the Condorcet method has checks everywhere, which means it is judged to be good according to all of these different ways of judging. But the Condorcet method, as we all know, doesn't always choose a winner, and so it's actually not appropriate to use in real-world, large-scale elections. You can try to do it, and sometimes you'll get lucky if there is a Condorcet winner, but generally speaking, there won't be, and so it's not a system that we can generally use in the real world. Maybe you're wondering, it's a shame there isn't another one, like a real other system, which actually has a check everywhere, right? And I said, like on Wikipedia, there's a bigger version of this chart with more and more systems. It's natural to wonder, has anybody come up with a system that actually does have a check in all of these 5 columns, and perhaps some more columns that we haven't even talked about? There's an answer to that. So this was work done actually in the 1950s. In the 1950s, a guy named Kenneth Arrow. This is an American, he's actually an economist, but sort of mathematical type economist. Kenneth Arrow asked sort of the basic question, can we design a system which satisfies all of these properties? Can we design a system which satisfies them all? And I'll say parenthetically, and always chooses a winner. Like, that's the bad thing about the Condorcet method. It does satisfy them all, but it doesn't always choose a winner. And always chooses a winner. Can we design a system which satisfies all of those properties and also chooses a winner? And Arrow discovered the answer is no. And he ended up proving what is now known as Arrow's impossibility theorem. It says, actually, it is mathematically impossible for a voting system to satisfy all of those criteria. And in fact, it's even sort of, this is kind of bad news for voting in the real world. It means if you want to imagine sort of a perfect voting system, actually that's not possible. And it's not possible. It's not like because we haven't figured out the perfect voting system. It's because actually, mathematically speaking, it cannot exist. There cannot exist a perfect voting system. Anyway, this is what I'll tell you exactly what the theorem says. It says the only voting system possible which always chooses a winner. So this rules out the Condorcet method. Always chooses a winner and satisfies IIA and unanimity. In fact, you can't even satisfy both of those. Actually, unanimity. There's only one voting system which satisfies both of those, the IIA and the unanimity. And what is it? You can see it on the chart, actually. The Condorcet doesn't count because it doesn't always choose a winner. Which one is it that satisfies the IIA and the unanimity? The dictatorship. I heard some people mumbling. Dictatorship. Yeah. The only voting system possible which always chooses a winner and satisfies the IIA and the unanimity is dictatorship. All right? What it means is, sort of mathematically speaking, the only perfect voting system is dictatorship, which obviously is not something that we want to use in the real world. All right? It's a bit of a bummer. This is something that Arrow did. Arrow actually won the Nobel Prize in economics, not for this, but this is what he's most well known for among mathematicians, is the Arrow's impossibility theorem. So can I just say, this means basically there cannot be a perfect or best voting system. All right? Because you can't even, it's not even possible to satisfy just those two properties. The unanimity and the IIA cannot both be satisfied. And there are actually many other impossibility theorems in the mathematical theory of voting that say other things, like you can't have a voting system that has this or that good property. And let me just say, what I mean here, I will say this like parenthetically here. I don't mean we haven't found a perfect one yet. I mean, it's impossible. Right? In common parlance, when somebody says something is impossible, sometimes what they mean is nobody's ever done it yet. That's not what I mean, though. Arrow actually proved mathematically that it's impossible to have a perfect voting system. And so it's not that nobody's figured it out yet, or maybe someday someone will come up with it. Sometimes when I tell people this, like in people who are not mathematicians, sometimes people ask me, in the club or whatever, what classes do you teach? And I say, I teach calculus. Sometimes I teach this other class that's for English majors or whatever. Oh, what do you talk about to them? So I say, talk about voting. And most people think what do you even say about voting? Because all voting is like you add up the votes, right? And then no, actually, I mean, that's what I suppose most people think of it that way. But actually, there is a lot to say about voting. And one thing I'd say is one of the punchlines, interesting fact, is that actually there are mathematical problems with all voting systems. You can't actually design a perfect voting system. And a lot of times the response is like, oh, all right, well, I guess you better get to work on that. Like, if you can't have a perfect system, you gotta just try harder, and someone will come up with it someday. And I have to say, no, that's not what I meant. I mean, actually, it is impossible. Not that I can't do it, or you guys can't do it, but actually, it is mathematically impossible. Some people say, well, you can't prove a negative, right? Wrong. You can prove a negative mathematically speaking. Legally speaking, I don't know about that, but it's an interesting thing. I think. Tell your moms, see if they're interested. I think it's something that once you get into the details of it, maybe your eyes start to glaze over and you can lose interest because you're lost in the details. But actually, it is an important and interesting fact to know. Any questions about that? Any thoughts? Does this change your dedication to the concept of democracy? To me, it doesn't really. It just means that democracy, I suppose, as a concept, is a little more complicated than I thought it was. It doesn't mean that I'm into dictatorship, although the dictatorship does satisfy the IIA and the unanimity. All right, great. Let's talk about something a little different. I have one more thing. I want to talk about another impossibility theorem. Like I said, there are actually several different impossibility theorems. The most famous and historically speaking, the first one was Arrow's theorem. And then after Arrow's theorem, it was so sort of inspiring to other people that a lot of people started looking for other kinds of impossibility theorems that say something like no possible voting system could ever have this or that property. And what I would like to talk about for probably the rest of today, I don't know. Maybe we'll get through this. I want to talk about one last thing concerning voting systems is manipulability. Manipulability. Can a voting system be manipulated or not? This actually, ordinary people, this comes to mind when you try to explain to somebody a more complicated voting system that's not the plurality. If you say, hey, no, I want to vote, but I don't want to use the plurality system, the one that, the normal way. I want to do it this fancier way, the instant runoff or something. And sometimes people get, suspicious of you, and they think, that's kind of weird rules. Isn't there some way that I could try to game the system? If the system is more complicated, it seems more susceptible to being manipulated or gamed. And I don't mean actual cheating in the election. I just mean people doing some funny business because the method that you're using is so complicated. Maybe there's some kind of loophole or something. This is the idea behind manipulability. So manipulating the system. In this context, what we're talking about is, can the voters shall I say, weird effects in the system by voting in weird ways. This is definitely a concern. If the system is super complicated, you might feel like maybe there's some weird thing that I can do when I'm voting. Maybe I can vote in a certain way, which causes a weird effect to happen in the system. All right? And in particular, what I want to focus on when we're talking about manipulability, I'll write this as a definition here. A voting system is called manipulable, and this is bad. In the real world, you want your system to be totally transparent, that in the sense that nobody can game the system. A voting system is manipulable if voters can achieve a better result. What I mean by better is in their own opinion. By voting differently from their true preference. All right. Manipulable means that the system is so complicated that the voters can actually, there's some sort of weird loophole where they can actually achieve their best result by voting in a way which is contrary to their preferences. This is like, you could imagine if we're using some very, very weird voting system where it's so complicated, like you don't even really understand the rules, and I'm like, oh yeah, I really like that Trump guy, so I'm going to put Trump on the top of my rankings. And then my buddy who understands rules, he's like, no. Check it out. The rules are so weird. Actually, if you put Trump second, then some weird stuff is going to happen. That's actually going to be better for Trump. That kind of thing, we don't want that to exist in a system. Our system should be designed so that however I want to vote, the guy I like the best, I should put them on the top, and that actually will work out for me. Rather, like there is no incentive for me to somehow put somebody else on top to somehow make my guy win, even though I'm putting them lower down, right? This is the idea. So manipulable is a bad thing, and it means that the voters actually can get a better result, better for themselves, better in their own opinion, by voting in a different way from their true preferences, all right? Let me just say, this is generally bad. That's because we want to encourage the voters to just decide how they feel and vote that way, right? Rather than the voters having to pre-plan on voting in some weird way based on some strangeness in the system. So we want voters to be able to just vote how they feel, right? You don't want the voters to have to think about how I feel and then also think about how do I vote in a way which is consistent with the details of the system so that my vote will actually count as best as it can for me, right? It turns out, actually, even simple voting systems do not satisfy this sort of, simple voting systems are manipulable, all right? A voting system is manipulable. It means the voter not only has to think about their actual preferences, but they also have to think about the way in which the votes are being counted, and maybe they should vote in a different way to obtain the best result. For example, what about the plurality system? We are so accustomed to using the plurality system that I think most people just sort of assume that there are no manipulations involved when you vote in the plurality system. But this actually is not the case. The plurality system is manipulable. That means actually when you vote, voters do have an incentive to vote differently from their true feelings in order to obtain a better result for themselves, all right? This is something that I think all voters in America have this in the back of their mind, but they don't even think about it. All voters are actually not only thinking about their true preferences, but they are also thinking about how the votes will be counted and voting in a way which will cause the best output. So, for example, let's look at Bush, Gore, Nader. Remember that one? My favorite real-world example. 2.9 million said Bush, Gore, Nader. 2.9 million said Gore, Bush, Nader. And then 0.1 million said Nader, Gore, Bush, right? And using the plurality system, as we do in Merca, Bush wins, right? With the plurality. Just based on the chart, it's a tie, but you know, in the real world, the vote count for Bush was slightly higher, to the tune of 500 votes or so. Bush wins with the plurality system. And the thing that we've been saying all along is these Nader, Gore, Bush people, these ones, to get a better result, better, I mean in their own opinion, to get a better result, should have voted Gore, Nader, Bush, right? If they had voted in that way, Gore would have won the election instead of Bush, which in their own opinion, I'm not saying it is better that Gore would have won. I mean, in these people's opinions, this would be a more favorable result, all right? So these ones, to get a better result, should have voted Gore, Nader, Bush. It means these Nader voters, they should not have voted their true preferences. It would have been better for them if they instead voted for Gore on top, even though Gore was not their first choice. All right, so these Nader folks, the Nader people, the Nader voters would have gotten a better outcome if they voted contrary to their true opinion. Right? This is a bad thing about the plurality system. Although, like I said, I think most Americans don't really think about it, but it is true, and everybody knows this when you put it in a certain way. When you go to vote, you're not just voting for the person you think is the best. You're voting for the person who you like the best among the ones who are probably going to win, right? You don't vote for somebody if they're not going to win, even if you really like that person. You know, when I go to vote for the president, I don't write in my mom every time because my mom's not going to be the president, right? I vote for, you know, Trump or Biden or whatever because those are the only ones that are gonna that have a real chance of winning. So this means the plurality is manipulable. Plurality is manipulable. It probably doesn't feel like a manipulation when you vote in this way, but you are voting in a way which is different from your true preferences. I'm not saying everybody does this. Maybe you really do love Trump and Biden. But I think actually there are people who really love Trump. I think there are much fewer people who really love Biden. I'm really on the Biden train here, putting up Biden flags and everything. You don't really see that. They're voting because they think he's better than the other guy. Anyway, plurality is manipulable. That means sometimes it's best to vote in a different way from your true preferences. All right? These kinds of votes, this sort of voting contrary to their true opinion, this is called tactical voting. In a manipulable system, the voters are not always going to vote the way they truly feel. They're going to vote tactically. That is, they think about not only what do I really feel like, but who's going to win and how can I influence the winner, all right? In a plurality system, in American politics, everybody votes tactically, basically, because you're not voting for the person who you think would be the best president in the whole world. You're voting for the guy on the ticket who you think is going to win and who you think is going to be the best. All right? Is this kind of manipulation possible in other systems? That's what I want to talk about. For the next 20 minutes or so. What about the instant runoff? Is it possible to manipulate the system of the instant runoff? The answer is yes. Actually, we're going to show an example where some people can get a better result by changing their mind and voting contrary to their true preferences. Let's try. Here's an example. 6, 4, and 3. This, I suppose, is not a big surprise just because the plurality is manipulable, and I feel like I think of the instant runoff as sort of a slightly more complicated, more sophisticated version of plurality, because in each round you're still doing the plurality. I don't know if you feel that way. Anyway, let's say 6 people said A, B, C, 4 people said C, B, A, and 3 people said B, C, A. All right, what if we do the instant runoff? Let's just do it real quick here. Who wins when I do the instant runoff? In round 1, I count up the votes, right? A gets 6, B gets 3. We're counting up just the first position plurality votes. C gets 4. So B is eliminated. And then in round 2, it's just between A and C. And it looks like to me A is only getting those first 6, and C is getting 7. Right? And so C wins. I hope you remember how to do the instant runoff. This is what most of the homework is about. C wins if you do the instant runoff in that way. All right? Now, check it out. I would like to make a change here. I'm going to show you how you can actually make somebody different win by one of these voters changing their minds to vote in a way which doesn't actually reflect their true opinion. Let's assume that all of these original ones are like their real opinions. And I'm going to look at actually this first column here. Let's just take one of those voters and change them. So I'm going to change one of the ABC to BAC. All right, so the new chart will look like, now I have only 5 people saying ABC, 1 person that I just changed saying BAC, 4 people say CBA, and 3 people say BCA. Those are the old ones. All right, so I changed that. 6 people ABC is now 5 people ABC, and one of them changed their mind and said BAC. All right. So what we had here is this person who liked A the best. They actually dumped A down a little bit and put B on top instead. All right. Now, what happens to the winner here? So I do the instant runoff again. Let's see. Did the result change in the first round? This time, the round 1, right? A has now 5 up top. B has 1 and 3 is 4 on top, and C also has 4 on top. We have a tie, and remember, what do you do when there's a tie with the instant runoff?
You just delete them.
Yeah, we eliminate both of them, and so now A wins. All right, check it out. We had one of these people who liked A the best. They decided to dump A down, and that actually made A win. Isn't that a little crazy? I think that is a little crazy. But anyway, this is an example of showing how one of these people can actually get a better result by changing their vote contrary to their true preferences. All right. So it is a true fact in the instant runoff system, when you are voting, you don't only think about who you like the best, but you also have to think about how the result is likely to come out, and maybe you can get a better result by voting in a slightly different way. All right. This actually gets very complicated in the real world in places that use instant runoff. There's a lot of discussion about tactical voting, like right before the election. And in fact, you can, there are like people's campaigns set up websites about instructing people on how to vote tactically. They say you don't necessarily want to vote just the way you feel about everybody. You should actually vote in a fancier way to get the best outcome. All right. So anyway, the instant runoff is manipulable. And there's actually a theorem about manipulability And this is in the spirit of Arrow's theorem, which says there's no perfect system in the sense that no system can satisfy IIA and unanimity. There's another theorem. So this is named after two people who both have great names. This is called the Gibberd. That's the first person. And Satterthwaite. The Gibberd-Satterthwaite theorem. It says basically all systems are manipulable except dictatorship. So I'll say it the other way around. The only non-manipulable system is dictatorship. All right. So this is another kind of impossibility theorem. It means that it's impossible to have a real voting system that cannot be manipulated by the voters. Every system, there is some incentive for the voters to think about voting tactically, which is kind of a bad news. It means that's just a thing that is permanently built into democracy as a whole, is that voters are not advised to just vote their true feelings. They are. It is in the advantage of the voters to think about the way the votes are counted and vote tactically accordingly. All right. This is actually extreme. Manipulability is extreme in the Borda. I want to do one example. Manipulability is extreme with the Borda. I want to do one example, and then actually this will be the end of this business. Check it out. I would like to talk about the Bush-Gore-Nader election if we used Borda. Let's look at the Bush-Gore-Nader. With Borda, all right? Now, the original votes, so the real votes were, I will refresh your memory, 2.9 million people said Bush-Gore-Nader, 2.9 million said Gore-Bush-Nader, and 0.1 million said Nader, Gore, Bush, right? Now, when you're voting in the real world with Borda, actually this, remember I said, most places in the world, democracies use the plurality system. Many places use the instant runoff. Almost nobody in the real world uses Borda. Actually, what I'm about to say is why people don't use Borda in the real world. It's because crazy things can happen if you use Borda in the real world and people vote tactically, which they do vote tactically. People will always vote tactically in the real world, just like we do in the plurality system. That's why I don't vote for my mom to be the president, because I'm voting tactically. You should expect that everyone in your election will be voting tactically. Anyway, let's say these are the real votes. And one common tactic in the Borda, and it's very effective, and so if you're using the Borda in the real world, you should expect the voters are going to do this. One common tactic is called dumping. It means if you have one of your people on your ballot who you think might win but you don't want them to win, you dump them all the way to the bottom to give them 0 points, all right? So what this looks like is the Bush-Gore-Nader people. This is how they truly feel. They like Bush and then Gore and then Nader, but they know Nader's not going to win and Gore might win, so when they go to vote, they're going to dump Gore. So these people will vote Bush, Nader, Gore. That's because they know they're using the Borda, and they don't want to give Gore any points. They want to dump him down to the bottom, all right? This is a common tactic that you should expect. If you're using the Borda in the real world, you should expect all the voters to do this, all right? By the same reason, the Gore, Bush, Nader people will vote. Well, what do they say? Yeah?
They'll do Gore, Nader, Bush.
Gore, Nader, Bush, right. Even if they don't want Nader to win, they know Nader's not going to win. And so they will dump Bush down to the bottom to avoid giving Bush any points, because Bush is their enemy. All right? And then the Nader, so the Nader, Gore, Bush, actually, they probably are going to vote that way. The Nader, Gore, Bush, their least favorite person is Bush. And they already put Bush at the bottom. They certainly wouldn't want to dump Gore because they kind of like Gore, right? So actually, these people will still vote Nader, Gore, Bush. And can we say what will the actual results be? If we make these changes, what will the results be? Come on now. So after making those changes, the election will now say 2.9 say Bush, Nader, Gore. 2.9 say Gore, Nader, Bush. And then 0.1 say Nader, Gore, Bush. Let's add up using the Borda, all right? If you run an election using the Borda, you should expect that voters will behave in this way because they're smart enough to know they should dump the people they hate the most, all right? Somebody who really hates Trump, they're going to put Trump on the bottom, even if that means putting their mom up higher, to make sure Trump doesn't get any points from me. Anyway, what do we get? So the Bush votes is going to be 2.9 times 2 from the first column, plus 2.9 times 0, plus 0.1 times 0. That's 2.9 times 2 is 5.8, all right? I'm doing the Borda points in the usual way. The Gore votes is going to be 0 from the first column, 2.9 times 0, plus 2.9 times 2 from the middle column, plus 0.1 times 1. This adds up to 5.9, a little bit better. And then the Naders, as usual, the Naders. 2.9 times 1 point from the first column, 1 point from the second column, 2 points from the last column. What does that add up to? 6. Can you believe it? Nader wins. He pulled it out, finally. All right. What I'm trying to demonstrate here is crazy things will happen if you use Borda in the real world because people will vote tactically, and it has a huge effect on the result. Like, say what you will about Ralph Nader, he should not have won this election, right? Any system which is going to make Nader the winner is probably, suspicious, a little sus when Nader starts winning presidential elections. All right. So the moral of the story here is Borda is kind of viewed as dangerous to use in the real world because tactical voting, if you're using Borda, has sort of especially disruptive effects. Tactical voting can cause very weird outcomes, such as Nader winning that election. All right. They can cause people to win the election who really almost nobody wanted them to actually win. But because everyone individually is voting in their own best interest, it causes the result to be totally wild. And this is why actually this is the principal reason why Borda is not used in the real world. And even Borda himself, the guy who came up with this method, was aware of this thing. And there's a famous quote about Borda. He said he thinks Borda really liked the Borda system, but he said my system is intended only for honest men, meaning like you have to be sure that the people are going to vote honestly, because if they start monkeying around by dumping their opponents, weird things can happen in the outcome. All right. And that's all I wanted to say about manipulation. So all voting systems are manipulable. We got 5 more minutes. I think that's time to do one last thing. I had one more thing to say about this kinds of voting methods and criteria and all that. Yeah, maybe not. I'll leave it to next time.